Assalamu alaikum. Welcome to another live stream. We are continuing our series on orphan genes. This has to be, for me, one of the most precious things on YouTube, better than all those videos speaking about how mutations and selection can create anything. Let's talk about the evidence. So I'm back with Paul Nelson. Paul, this series for me is something which I think if people understood even 10% of it, it would dispel all of those images about Darwinism being so strong scientifically. I mean, would you say that's an overestimation? Would you say that's about right?
Well, I think that taking the design perspective, which encompasses actually the valid parts of evolutionary theory, gives you a much greater range of options when confronted with any biological puzzle, and for that reason, it liberates you.
Yeah.
I think that this bondage to the limited set of tools that evolutionary theory, naturalistic evolutionary theory provides, is something that people should want to be free of. No one wants to be a slave, and being a slave to this limited explanatory framework, I think, is a dreadful thing. And what I love about intelligent design is it, as I see it, does not take anything away from biology.
Yeah.
As a science, it does challenge naturalism, but that's a wholly different question.
Yeah, I really love the way you put it there, because we are not science stoppers, we are science facilitators. So let's get cracking with the presentation today, because I think a lot of people are going to find this information very interesting.
Wonderful. So I am on a long journey towards the big finish of this series, which will bring us back to orphan and taxonomically restricted genes. But to do that, I needed to make a side trip into some philosophical analysis and some issues in evolutionary theory that will tie back into the relevance of orphan genes for biological understanding. So we are now in part two of one of these digressions, which is how a systems first top-down perspective on living things can be empirically fruitful. So today I want to talk about functional analysis and what I'm calling the intrinsic limits of evolutionary reductionism. So just as a little preamble, we need to be cautious about thinking of intelligent design as simply the logical negation of evolutionary theory. So on the top of the slide there, you see in the blue box a little logical formula: negation, evolution, ergo, or therefore the horseshoe symbol, intelligent design. And it really doesn't matter what the particular flavor of evolution is, whether it's classic textbook neo-Darwinian theory or some variant of that. By evolution, one should understand a naturalistic account of the origin of living things and their diversification. Intelligent design as an alternative cannot simply be the logical negation of that theory. And this is something that has troubled me for a long time, because I think historically and today, many people think of design as simply gainsaying the claims of evolution. So if evolution says X, then intelligent design says negation X. Or if evolution says Y, negation Y, and so forth. So 30 years ago, I can't believe that much time has gone by. I wrote an article, a long article called Thinking About the Theory of Design. And in that article, I sketched a visual metaphor for the evolution versus design debate. And the image in the metaphor was that of an incomplete mosaic. So on the left here of the slide, you see a mosaic that's been partly finished. You have some branches of a tree there, leaves, and so forth. And I said in that article, the empirical content, that is what we say about the world from the perspective of design, couldn't be simply the open areas. so we can illustrate them here, right? The solid blue region. This is where the tiles have yet to be put in place. Now remember, the tiles in this metaphor are being put in place by the theory of evolution. So every scientific theory has unsolved problems and open areas. It's in the nature of science to generate such things, right? To come up with new problems to be solved. And evolution as a scientific theory also has unsolved problems. If we try to say, or if we say that design is simply whatever evolution hasn't yet explained, that makes design completely parasitic on the shortcomings of the standard theory. As a consequence, as more of the evolutionary mosaic is put in place, the area left to intelligent design necessarily shrinks. But if it can shrink, and again, I think the metaphor of the mosaic is helpful here. If we imagine that design actually put its own tiles into place in this solid blue region here, then they would genuinely be occupying some area of the mosaic. But if there's nothing there, then evolution can expand, and then intelligent design isn't actually saying anything. And then, as I say in the article, the content of intelligent design would be governed entirely by whatever problems are unsolved by evolutionary theory. So how to fix this problem, which is a philosophical problem in the structure of intelligent design? Come up with your own expectations. Project those into the space of biological science. And those predictions, those expectations should not be dependent on whatever shortcomings evolutionary theory may suffer at the moment. Remember, we want to get intelligent design standing on its own two legs, to use a different metaphor, not parasitic on the shortcomings of existing theory. Now, this is hard. In fact, it's much harder than simply critiquing evolution. But in the long run, and the short run for that matter, it will be by far the most productive approach. All right. One dimension of this practice, which I'm going to call intelligent design intellectual independence, involves thinking carefully before you adopt concepts from standard evolutionary theory. Now, there are plenty of concepts within evolutionary theory that are useful, they're empirically well supported, and they will be, in the future, incorporated into any mature theory of design. There are other concepts, however, such as selected effect function and fitness, that are highly problematic. And one doesn't want simply to borrow those concepts and import them into intelligent design as a theory, because they are going to bring along with them the conceptual explanatory problems that they had in standard evolutionary theory. So it's, if you think about very much along the lines of a real toolkit, right? I mean, here in my house in Chicago, or in the garage nearby, I've got, a toolbox, and some of those tools are very useful. I can count on them. I need them from time to time. Other tools, they don't work so well. In fact, they're problematic. And, I probably should just throw them away or recycle them, but they're still out there. In other words, not every tool I have in the garage is equally useful to me. Analogously, not every concept in evolutionary theory in the current formulation is going to be useful to an intelligent design theorist. The problem is these concepts, these problematic concepts, may presuppose limits or restrictions, which as a design theorist, we have no reason to accept, because our framework of explanation allows for much more. So in this presentation, I'm going to focus on these two concepts, selected effect function and fitness. They will turn out to be relevant when we come back to orphan and taxonomically restricted genes in the concluding sessions of this series. So here's my outline for today. We'll first explain what a selected effect function is and how it has its roots in the notion of fitness. Then we'll do a somewhat extended thought experiment about what are the functions, or what is the function of a steamship. And if that seems odd to you now, believe me, it will be relevant and make sense in just a few minutes. Then we're going to ask in a more general way, how is it that a function can become invisible to analysis, which is a big problem with that flows directly from these notions of selected effect function and fitness. Lastly, we'll look briefly at what I'm calling the causal freedom of a designer. And again, the goal today, as it was in the last session, is to illuminate the theoretical advantages that are conveyed by the design framework as what I'm calling top-down, systems-first perspective. All right, selected effect and fitness. So over the past decade, maybe decade and a half, there has been raging within biology what we can call the function wars. And the function wars have their roots in 19th century evolutionary theory. Actually, you can go back to antiquity in the writings of someone like Lucretius to see the same concepts at play. But we'll pick up the story with modern evolutionary theory. In particular, the question, what portion of organismal genomes is functional? Now, it's remarkable for an idea that supposedly died in the mid-19th century with the publication of The Origin of Species, namely intelligent design. It still is very much the driving motive behind much of what has been published in this area over the past 20 years. To be more precise, dislike or loathing of intelligent design has been the driving motive. So it's easy to multiply examples on this head. Dan Grau, who is a wonderfully outspoken geneticist at the University of Houston, and I'm not being facetious when I say that, Grau speaks his mind bluntly, sometimes too bluntly, but I admire his candor. I like people who are straight up, straight shooters. They tell you exactly what they think and let the chips fall where they may. So with no irony or sarcasm intended, Dan Grau is plain spoken, wonderfully plain spoken. So in 2016, he published a textbook with Sinauer, Molecular and Genome Evolution. I actually have it here on the shelf. Very good textbook. In there, he says, look, genomes are the products of evolution rather than intelligent design. As a consequence, all genomes contain functional and non-functional parts. Why? Because evolution is an undirected natural process. It is not concerned, in fact, we can't even really properly assign it motives or directionality. So these are all manners of speaking to say evolution is not concerned. Evolution is a natural process, does not keep your genome as tidy and functional as possible. Your genome is a product of history. The genomes of all organisms are products of history. History is just one damn thing after another. If you are able to reproduce and your genome enables the operation of a viable cell, a viable organism, good enough, right? No perfection, no good design. So there are direct consequences for observation in the causal story that one tells about the origins of genomes. So Grau's pointing that out and saying, look, evolution gives you very different expectations from a theory of design with respect to what one should see in a genome. Larry Moran is a emeritus professor of biochemistry at the University of Toronto. He and Grau think very much alike in this regard. He just published a very readable book, which I have right here. What's in Your Genome? 90% of your genome is junk. published by University of Toronto Press. In that book and at his blog Sandwalk, he's been very clear that intelligent design as a causal story gives one a very different set of expectations about what should be present in the genome. Moran is particularly concerned about the human genome, as you can see from the subtitle of the book, Your Genome. But he would generalize the point to any organismal genome. And he says, intelligent design creationists have been predicting for years that most of our genome would turn out to be functional. Why? Because a genome full of junk doesn't look like the work of an intelligent designer. So ENCODE, this massive multi-center research project to look at the function of not just the protein coding sequences, but which is a small fraction, 2 to 3% of the genome of human beings, but in fact, look at all of, as much as possible of our DNA for possible functional roles. When they published in 2012, big burst of publicity, claims that 80% or more of the human genome was likely functional. This was headlines. You'll remember it if you were paying attention. Now, what's going on sort of behind the scenes? Well, there are consequences. If it turns out, consequences theoretical and otherwise, if it turns out that most of the human genome is in fact functional. In other words, reverse the subtitle in Moran's book and say, 90% of your genome is functional. That will have consequences for our understanding of the origin of the human genome. And the initial claims, somewhat retracted by many of the ENCODE investigators, that most of the human genome was likely functional, those claims were picked up by the intelligent design research community because, in fact, they had been saying, as Moran points out, for a long time, predicting, in fact, that most of the genome would turn out to be functional. Now, this slide is actually the work of Dan Grau. It's, in fact, a screen capture from a talk that he gave in 2013 at the Society for Molecular Biology and Evolution here in Chicago. And again, as I said a moment ago, Grau is very plain-spoken, and he said, look, if ENCODE is right, and the great majority of the human genome is functional, then evolution is wrong. And this is his actual slide, and he has a book by my Discovery Institute colleague, Jonathan Wells, the cover of the book there, The Myth of Junk DNA. So there's a direct connection between what one says about the functional content of the human genome, or really the fact is for any genome, not just human, any animal, any prokaryotic. The point can be generalized. Now, Grau is saying ENCODE, the initial claims of ENCODE, I believe the figure was 80%. They were in the initial publicity, they were saying, we think that 80% of the human genome has a functional role. Grau says, look, that has to be wrong. That 80% has to be wrong, because if it isn't, evolution itself will be wrong. Now, we might ask Grau and Larry Moran, and this is W4 Doolittle at Dalhousie University in Nova Scotia, another advocate of junk DNA. We might ask him, well, why would you say that? So work your way backwards logically from this claim in the yellow box, or the yellow rectangle there. The underlying reasoning is not hard to find for saying ENCODE must be wrong. Why? Evolution occurs strictly via accumulated differences in reproductive output caused by undirected natural processes. There's no foresight or purpose. There's no design. And by evolution, we should understand the origin of novel forms, and biological complexity, which go hand in hand. So as you work your way backwards logically from a claim like encode must be wrong, because if it's right, then evolution itself will be wrong. Work your way backwards in the chain of logic to the causal story, and you find that what's operating in evolution is accumulated differences in reproductive output, which we'll talk more about in just a moment, via undirected natural process. So if that's what you think caused us to come to be, that gives, again, expectations about what the genome should look like. So foresight or purpose, which was perfectly real as a cause to Linnaeus or to Newton or to Boyle or to Cuvier or to Agassiz. So the majority opinion of pre-Darwinian biology and natural history was that purpose and foresight were real causal forces bringing about eyes, ears, limbs, brains, guts, and so forth, the adaptive complexity of life. And with the Darwinian revolution, foresight, purposeful action is taken off the table. It's no longer a viable cause. And Kunin, in this article with Yuri Wolf in 2007, they say, look, evolution has no foresight. Almost by definition, one could say. So what you observe cannot be explained by any process with purpose. What do you have to work with as a consequence? Fitness. Fitness is the one term or the one word designator for accumulated differences in reproductive output. Now, fitness for that reason sits right at the center of evolutionary theory. And fitness differences in populations are both the cause and the outcome of evolutionary transformation in time and space. So you, the viewer watching this on YouTube or wherever, you exist today because the very long sequence of your ancestors, not just your human ancestors, your primate, hominid, mammalian, vertebrate, work your way back down the tree of life, ultimately to Luca, the last universal common ancestor. The fact that your ancestors left as offspring reproductively capable organisms, that explains why you're here today. Organisms that didn't do that either went extinct or that simply failed to leave reproductively capable offspring, their lineages died out. The lineage that reached you, the viewer, didn't die out. That's why you're here. So this is a core notion in evolutionary explanation. Differences, accumulated differences in reproductive output. And by and large, and this may not be the case in 5 to 10 years. I don't want to, get in the tricky business of making predictions about the future of evolutionary theory, but it is a rapidly shifting landscape with respect to within the discipline of biology, with respect to the explanatory adequacy of neo-Darwinian theory. But I think, by and large, my best estimate for current opinion is if you went to an academic biology program, so here in University of Illinois or University of Chicago or Northwestern, institutions here in the central United States, chances are most biologists would say natural selection as a causal process is largely the responsible party, so to speak, for why, I've got this well-designed hand and so forth. So Deborah and Brian Charlesworth and Nicholas Barton in a paper in 2017 said, look, allele frequency change caused by natural selection is the only credible process underlying the evolution of adaptive organismal traits. And I think that is a statement that would likely win the assent of most academic biologists. Although, as I noted a moment ago, increasingly there's opinion that this is no longer true, that there are other processes that are equally important. So very briefly, let's look at natural selection, because I want to focus on this critical factor of fitness. So natural selection, in the formulation that I'll use, is expressed as a conditional. If, which is a logical marker of a conditional, 3 conditions are satisfied. First is variation. There need to be differences in a population of organisms. So here we have some tigers, some stickleback fishes, some ladybugs. Just from visual inspection, you can see that there are differences among these members of these populations. And those differences need to make, here's some differences within Homo sapiens. Although it's interesting when you think about Homo sapiens, look at our genetics, we're basically a clone. One human genome is largely the same as any other. That's not true as you move out into the primates. There's a great deal more of genetic variation in our nearest evolutionary kin than in Homo sapiens. But we still have a lot of variation. That variation needs to make a difference to the number of offspring that you leave in a consistent way. Let's call that the condition of selection. So here, let's say, is a eukaryotic, single-celled eukaryotic organism reproducing by binary fission, and we introduce a selective condition, the black bar. Let's say we raise the temperature, or we introduce a toxin into the chemostat where these critters are growing. And the yellow trait, whatever it happens to be, enables survival and reproduction, whereas the orange trait does not. So we keep the selective condition in place, and you can see there's a demographic shift in the population as a whole, such that the yellow trait goes to fixation, where initially it was at a lower frequency than the orange trait. Under these selective conditions, the yellow trait prevails, and in fact, it's present now in all members of the population. Lastly, heredity. You must be able to transmit the variations in a stable way to your offspring, and that stable transmission is critical. So here I've added another generation. I actually took out the selective condition and let this population expand dramatically, doubling in size. Each of these red arrows indicates the successful transmission of a trait. So if these 3 conditions are satisfied, you will have natural selection occur. Now, without successful transmission, no evolution. But in fact, all 3 of these are required. All 3 of these conditions are required. They're both necessary and sufficient for natural selection to operate, to change the frequency of trait Q between the population of all parents and the population of all offspring. And this formulation, by the way, is due to the work of John Endler and the late Richard Lewontin. So, simpler way to think about it, 3 legs of a stool. Again, all the legs are required. These conditions are necessary and sufficient for the operation of natural selection. Now, as I said a moment ago, there's increasing skepticism about the explanatory adequacy of the neo-Darwinian framework, where selection, natural selection, occupies center stage. So someone like Michael Lynch at Arizona State has been very outspoken about what he regards as the deficiencies of selection. He says, it's become a little more than an exercise in dreaming up supposed agents of selection. And this is a problem. He said, this unwavering belief in the limitless power of natural selection is untenable. In fact, he's even more blunt, and you can see this for yourself if you go to his website and download the chapters of a book he's working on. He calls it religious adherence. which is pretty harsh criticism from an evolutionary biologist. Religious adherence to the view that selection is solely responsible for diversity, he says this is a pervasive problem. However, and this is a critical slide, any evolutionary process, genetic drift, self-organization, natural genetic engineering, take your pick on the full buffet or serving table of different possible evolutionary theories. Any evolutionary process must satisfy the following. You have to have new variation. Those variations must track with differences in reproductive output, what I'm calling fitness. And you must be able to transmit them stably from parent to offspring. And this is not negotiable. Any evolutionary process, by definition, if you think about what evolution is, it is new things that arise, that take over populations, and that are stably transmitted from one generation to the next. In particular, fitness, which I'm describing as differences in reproductive output, has to be there. Okay, you've got to leave more offspring, because what one wants to do in evolutionary explanation is shift populations over time from state A to state B to state C in a way that is directional, that is stably transmitted. Now, this may be an even more important slide. Your role as evolutionary biologists is to explain the changes that we see in the fossil record, the changes that we see in current populations and so forth. And you go into your toolbox of possible causes. What do you find? What you find is fitness, causal differential. It's the only one relevant to the transmission of information. If you go extinct, or you don't leave any offspring, you are invisible to the process of evolution. And again, this applies across the board to all evolutionary theories. So what you have as you're explaining some puzzle is an analytical bottleneck at the notion of fitness, where the ancestral population is going to be funneled in your analysis, in your explanation, through fitness to the descendant population. As a consequence, if fitness is the only thing that is real with respect to outcomes, reproductive outcomes, to assign function to an organismal feature, whether that's a gene or a protein or an anatomical structure or a behavior, it doesn't matter, you must be able to demonstrate its contribution to fitness, where that concept is defined in terms of reproductive output. This analytical bottleneck ends up being highly problematic. Time for a thought experiment to show why it's problematic. And this is going to be now my steamship example, which I said might seem a little weird, but it's going to make sense, I hope. All right, what is the function of a steamship? So I'm taking the example from a famous novel by Jules Verne, Around the World in 80 Days. Published in the late Victorian period, and also made into a film in 1956. So at this point in the narrative of Around the World in 80 Days, Phileas Fogg and his assistant have to travel from New York to Liverpool, to London via Liverpool. All right, why is that critical? Well, it's critical because Fogg made a bet with the members of his club that he could circumnavigate the globe in 80 days, and there was a great deal of money riding on this bet, but he had to do it within the 80-day interval. So he's fallen behind his schedule, and he's got to cross the Atlantic at very high speed, sort of late 19th century high speed. So he hires a steamship in New York to cover this distance, almost 3,500 nautical miles. in, enough time or less time than his bet. So he's not going to lose all these, pounds sterling that he's wagered on being able to do this. Okay. What does he do? Well, here's a still from the film. There's Shirley Temple playing an Indian princess. She's on the bridge with Fogg. The Henrietta is the steamship in question. And what happens is they're crossing the Atlantic and they run out of fuel. All right. So on the 18th of December, the coal gives out to feed the boiler for the engine. So Fogg buys the Henrietta for $60,000 and gives an order to the crew to burn everything, every part of the ship not needed for the fastest possible forward motion. Okay, so on the 18th of December, the poop deck, cabins, bunks, spare deck are burned. On the 19th, the mast, rafts, and spars are burned. On the 20th, the railings, fittings, the greater part of the remaining deck, and the top sides are burned. He needs the fuel. It's quite dramatic in the film if you watch it. The sailors are pretty much okay with burning everything, but they don't want to burn Henrietta, who this female figure who's at the bow, right? She is this character who gives her name to the ship, and they have some affection for her. And in the scene in the movie, they're bringing her in, and the captain goes, "No, don't burn Henrietta," but she goes into the boiler as well. All right. And this is how the ship looks. There is David Niven playing Phileas Fogg, standing at the wheel. You can see what remains. Well, obviously the hull and the paddle wheel, or the dual paddle wheels, and the boiler and the engine and so forth. The steering apparatus. Only what is necessary to get to Liverpool as quickly as possible. Everything else that could be burned has been burned. Now, let's do a two-axis plot here, where on the vertical axis we have the number of distinct steamship parts required. Along the horizontal axis, we're going to specify our global function. And we can say, well, reach Liverpool as soon as possible. That's what Fogg is trying to do. But we could also have, and let's say 2,000 parts are needed. You have to have them to do that. You can't, for instance, burn the hull because the ship will sink. So the hull is essential for this particular global function. Reach Liverpool as soon as possible. But how about this one? A commercial vessel that's habitable by a crew. Okay, that's more problematic because that's going to raise the number of parts required significantly higher than reach Liverpool, right? Because you need bunks. The crew needs to sleep, right? So you can't burn the bunks. You can't burn the table in the galley where they're going to eat their meals. So if this is our specified global function, the number of parts required is going to increase dramatically. Well, how about this? A pleasant commercial vessel. A pleasant commercial vessel might have deck chairs where in their off time, the crew can relax or the passengers can sit and watch the water go by. It will have shade, shaded awnings to keep you out of the hot sun. You might put the masthead back, or whatever the name of the figure is on the bow of a ship. Henrietta might go back there just because it's nice to have something like that, right? So as you change the specified global function, the number of parts required on the vertical axis goes up in direct relation to how you have described the global function here. Now, let's say we're going to do what Fogg did, and we'll define the function of a steamship to which everything else is subordinate, is to travel as fast as possible across the Atlantic, to reach Liverpool in the shortest time possible. That's our global, or we're going to call that our selected effect function. What will happen is these other functions will tend to disappear. they'll become impossible to see or detect if we focus simply on getting across the Atlantic. If we say, in fact, that that's the only real function, then in a sense, the other ones don't really exist because we can't connect them to our selected effect. Now, this is not a biological example, but it is an example of a complex system and how one defines the functions of a complex system in relation to the parts of that system. So if you think of living things as nesting within the larger set of complex systems, the same logic will apply when we turn to biology, as you'll see in a moment. So let's do another non-biological example just to pump our intuitions a little bit at this point. Let's say the selected effect function of any automobile is to transport a passenger from point A to point B. Well, the Model T does that, right? You're sitting there in the cab or the passenger compartment of that automobile, and you crank it, get the engine going, and you can go from A to B. All right. A Toyota Prius does the same thing. At this point, these vehicles are equivalent with respect to, let's call the selected effect function going from A to B as a transport vehicle. But what's present in the Prius? Let's say a 2023 Prius. Well, things like a catalytic converter, power windows, air conditioning, CD player, USB ports, and on and on. There are all kinds of functions present in the Prius that have no equivalent in the Model T. Now, if we say that the only selected effect that is real is transport, and that's therefore the only effect that is descriptively and causally relevant, the unique functions of the Prius will tend to disappear analytically. Why? Because their direct connection to transport is difficult or impossible to establish. So there's no clear direct connection from a USB port in the Prius to go from A to B. Why is the USB port there? So you can charge your phone. So you can play your Spotify playlist, right? Plug it into the dash and so forth. A Prius is overloaded with functions relative to the Model T that have no direct connection to the selected effect function of going from A to B. And these will tend to disappear analytically if you have defined your selected effect function too narrowly. So a friend sent this to me actually just today. He was thinking about this same topic, and he emailed me this screen capture. Ripping the body off a Tesla Model 3 makes it way faster, which is probably true, right? Again, think in terms of, what do I want this thing to do? What do I want this complex system to do? Just to move me from A to B? Well, I don't really need a body for that, right? I need the wheels and the engine and the steering apparatus and so forth. So as you define your global selected effect or your selected effect function, the parts and their interrelations that are relevant to that will change dramatically. Okay, let's segue to biology now and take this notion of fitness. On our horizontal axis, so that's fitness defined in terms of reproductive output. That is our selected global or our selected effect function. And then again, on the vertical axis, the parts, although in this case, it's going to be the parts of an organism and their interrelations. Now, fitness is a very crude metric for function. Very crude. In fact, if you look in a textbook of population genetics or evolution, fitness is typically defined as a single numerical value given to or measured in terms of reproductive output, a single numerical value between 0 and 1. All right. just analytically, if you think about that, you are collapsing a great deal of information that you need to describe an organism into a single number. That should be troubling to you, because it's going to be very hard to go from that single number back to the information you need actually to describe an organism and what it does. But what fitness as a metric does, because it is so crude, is it pulls you down towards this corner of possibility space. Okay, now, my listener or a friend, my hypothetical skeptical friend that I'm always having conversations with, he says, come on, Paul, fitness is real. Every organism has a stake in its reproductive output. In fact, none of your audience would be here were it not for the reproductive success of their ancestors. And all right, I agree, fitness is important. Fitness understood in the sense of passing on your gametes, right? Passing on your genes to the next generation. But that's a different question from, is fitness the cause of what we observe? All right. If it is, stick with it. Okay, this is the move that Grau and Moran and Ford Doolittle and other evolutionary biologists make. They say fitness, it's the only thing that's real, leaving offspring. The only thing that's real in evolution in terms of a causal differential. Okay, I don't accept that. My view from a design perspective is reproduction is another function that organisms perform. It is, of course, essential. You don't want to go extinct, right? But it's not causally primary. Okay, I want to stress this point that this is going back to my opening slides. Don't borrow notions that are impoverished. And fitness, don't borrow notions that is from evolutionary theory that are impoverished. Fitness is very impoverished. Again, it is a single numerical value. In population genetics, it's stipulated absolute fitness is 1. Relative frequencies of genotypes in a population then will fall within that interval of 0 to 1. How can you sensibly go from that? Single numbers, right, on that metric to this. This is the parts list, or a partial parts list, of the proteins necessary for function in mycoplasma, one of the simplest free living cells that we know, bacterial cell. Okay. Proteins that do things like cell division or chaperones or elongation factor that operates in the production of proteins. Reductive concepts of function shrink possibility space. They pull you down towards this corner. So fitness, assessed as reproductive output, is going to pull you over here, down into this corner of your possibility space. And you say, well, look, everything that really matters is down in this corner because it's the cause of everything that we see. And again, this is the view of people like Dan Grauer, Moran, and so forth. But notice the opposite is not the case. If I have an open-ended concept of fitness, in the sense that I don't need to funnel everything analytically through that bottleneck, that analytical bottleneck of fitness, then I have a much larger space to work with. Think about it this way. A pleasant and crew-habitable steamship has to be a steamship to exist at all. So I don't lose anything by having a more permissive or comprehensive notion of fitness. Yes, you've got to get from A to B, but maybe it would be nice to have a well-stocked galley to do that, and some deck chairs, and some railings, and some awnings, and I can add functions to my core function without losing my core function. So I don't have to stay down in this corner. So here's my expansive concept of fitness. It opens up a much larger space. And biologically, if we think now about fitness with respect to production of offspring, yeah, you can still make babies, but making babies no longer has to explain everything. Reproductive output is still real, but it no longer has to carry an impossible explanatory burden of causing adaptive complexity to exist. And a number of theoreticians have noticed this. This theoretician, Pierre-Luc Germain at the University of Zurich, said, look, selection, which is a fitness-based concept, is neither sufficient nor necessary to understand function. It's a useful proxy, but it's imperfect, and it's not the only one. The problem is, if, like Dan Grau and colleagues, one has to build everything bottom up, starting from chemistry, the origin of life, somehow you get a cell operating, and then you're going to construct on top of that. You're building everything bottom up. You cannot start system first. What are your causes? What is in your toolkit? Well, leaving more offspring. That's what evolution does. The successful organisms are the ones that leave more offspring. We give that a name. We call it fitness. We assign a metric to it between 0 and 1. And just, who's leaving more genes in the next generation? That's how we score winners and losers in the evolutionary competition. That is a very limited toolkit of explanation. The problem is functional analysis, looking at a genome, for instance, and saying, what are these parts doing? Do they have functions? If in the back of your mind you have fitness built it, that is a reductive, limiting conception of cause and function, and it's going to pull you down into that lower left-hand corner of your possibility space and kind of stick you there. All right, almost done. Causal freedom of a designer. Now, design theorists face a challenge because current biological theory, current biological practice, just, going through a 4-year course in biology and then on to graduate school where you learn more biology, most of the people around you are going to be working in a reductive framework. And they're going to be down in this corner, okay, of possibility space. Now, I want to use another analogy to, I hope, illuminate why this is problematic. This will be the last kind of mini thought experiment in the talk, and then we'll have some time for discussion with Subor. So think of, on the vertical axis, words and phrases in a text. So if you can think of these, again, as the parts or modules of your complex system. Suppose your complex system in this case is a novel, like Melville's Moby Dick, right? Hundreds of pages of a story about Captain Ahab going after the white whale, and so forth. And the words and the phrases are the modules within that narrative, within that complex system. And let's say we have a reductive concept of function for that novel, namely that only the detectable actions matter. All right. So what that would mean is someone says, I want the Cliff Notes. Just give me the short executive version. Just tell me what happens. I just want to know, A happened first, then B happened. These are events in the narrative. So you say, you've got this big novel, Moby Dick. I just want the bare bones version. What happened? Give me the externally detectable actions or movements. So here's the first 2 pages of Moby Dick. And we read through this and we look at it and we're saying, this person wants just the externally detectable emotions or actions. Just tell me what happened. Guess what happens to these 2 pages? Most of it goes away. Why? Because it's describing the thoughts of Ishmael, his perceptions and reflections. It's not detectable. It's not externally detectable. He's walking around New York, right? But most of what's on the page is up here. It's not, in a film script version of this where you've got a camera set up or you intend to film this, you could summarize these 2 pages sort of like Ishmael walks around New York. Next page, right? Exterior, Ishmael walks around New York. All that text goes away that was relevant to Melville. Why? Because he wanted to tell a rich and interesting story, not just Ishmael walks around New York, now he meets somebody. Okay? You can see how your concept of function directly affects your perception of what's relevant in any complex system. Now, almost done. X has no function. Claims of that logical form are inherently sterile, and they're impossible to sustain evidentially because they have the form of trying to prove a negative. So we should have some sympathy for our evolutionary colleagues. And Larry Moran in particular has talked about this in his book, right? Which I was reading just the other day. He says, I can't actually prove that something has no function. Well, you know, in my correspondence with Larry over the past few years, I've tried to stress to him, when you say that X has no function, that is awaiting new research to overturn it. The very worst heuristic to have in biology is to say that something has no function. And history bears that out. Again, my starting point. If you take a concept like selected effect and fitness, or those paired concepts, because they have a close relation to each other, they may lead you into cul-de-sacs where you don't want to be. So again, my cautionary note, be very careful about what you take from evolutionary theory to build into your account of design. Not everything is going to be equally valuable and useful, and some of the concepts are going to be downright problematic. I like thinking about, I'm crazy, I like thinking about living things on a sort of science fiction or within a kind of science fiction framework where they are transcendently sophisticated designs. So we have a cute little bunny here and a mandarin duck. And over here we have some stills from Kubrick's 2001. If you have a high view of living things, you can have a high and a low view of scripture. The low view is, well, it's a humanly produced document. It's full of contradictions and pre-scientific understanding of the universe, and you know, basically it's not much there of value. A high view of scripture says this was inspired by God himself, and the more we study it, the more we'll see. Well, move from theology, Christian theology or Judeo-Christian theology, back into biology and say, what would a high view of organisms be? It would tell you that they are engineered at a level that's truly astonishing. It would take your breath away if you really understood it in detail. That is a much better heuristic for biological investigation. And frankly, I think more fun. All right, I'm gonna skip that slide. Told you about Grau and Doolittle. Well, John Matic is another person in the function wars on very much the opposing side to Grau and Doolittle, because Matic, who is not an intelligent design advocate, I need to be very clear about that. He's an evolutionary biologist or an evolutionary thinker. But many years ago, I think as a postdoc in Texas, if I'm not mistaken, he, I think under the influence of a certain amount of alcohol, he said, you know, why do we assume that the parts of the genome that we don't understand aren't doing anything? What value does that assumption have for learning new things? And he began to think about genomes in a very different way. And just a little over a month ago, he published a paper in Bioessays, fascinating paper, which I recommend to you. And again, I'll provide the references to Subor so you can go look it up for yourself. A perspective piece with the title A Kuhnian Revolution in Molecular Biology, Most Genes in Complex Organisms Express Regulatory RNAs. So here's my last slide. This is a figure from Maddox's paper where he compares 1980, 2000, and 2020. And the pie chart here shows the amount of the genome that was thought to be functional at these 20-year intervals. So 1980, you've got most of it non-functional. All right, the regions in gray here. Introns, hard to say, but probably not functional. 2000, look what's happened in this part of the pie chart. All kinds of different RNAs have been characterized. But you still have this very large non-functional region. Now, this pie chart reflects the view currently of Larry Moran, Dan Grau, and colleagues. Most of the genome is junk. This section of the pie is not going to get much bigger. That's what they're arguing. Matic, by contrast, says if we go out into these regions and we adopt more comprehensive notions of function, not necessarily tied to fitness in this quite limited sense of reproductive output, but take a high view of the genome as a set of mysteries awaiting elucidation, subtle functions waiting our analysis. He argues, there's a lot of function out there waiting to be discovered. My conviction is this is a much better heuristic for biological investigation, for discovery. And frankly, I would have this view even if I wasn't an intelligent design theorist. So that's my last slide. Yep, there's a black screen. So now Subbar and I can chat for a little bit.
That was brilliant. I had so many burning questions when you were presenting. In fact, I was thinking each one of these we could actually give a talk on. I mean, just something that came to mind because it was the most freshest thing. It's the last part where you were describing that the concept of function directly relates to what you think is relevant. And this reminded me of an incident which happened in 1861, where Darwin had to defend, obviously, his idea, which was quite controversial at the time. And somebody at the British Association of the Advancement of Science claimed that that Darwin should put his facts before us and let them rest, as in don't theorize, right? Don't essentially let the theory color the data. And Darwin said something very interesting, right, in response to that. He said about 30 years ago, there was much talk of that geologists ought only to observe and not theorize. And I well remember someone saying that at this rate, a man might as well go into the gravel pit and count pebbles and describe the colors. How odd it is that anyone should not see that all observation must be for or against some view if it is to be of any service. So, theory ladenness is so clear. We can see, and it's not something new, but I love the way that you described how, the example of, how a particular concept of, fitness being a metric, collapses all this data. I mean, this is happening all the time. We're seeing where, very complicated sets of information which are coming for us. Darwinists would just use certain sound bites or certain metrics and say, yep, that's been explained. And I think most people don't see that being the mother of the point, that this is one of the reasons why this theory still survives, because it's able to take such we can see there's outliners, there's data that clearly doesn't fit, there's things which are conceptually hard to fit into the current neo-Darwinian model, but they will simply collapse that data because of their concept of what is functional.
Right. And I think of it as this bottleneck analytically, where everything about you or everything about any species has to be funneled analytically through reproductive success. That's the only thing that matters. And a reductive bottleneck like that blinds you to what may actually be going on. And the really kind of ironic thing is, if you allow for more comprehensive notions of function, you don't lose reproductive output. It's still there. it's still there. We're still going to take a census who left the most offspring, right?
Yeah.
We can still ask why did they leave the most offspring, but now that concept of fitness no longer has to bear this impossible explanatory burden.
Yeah.
And frankly, I think for many lay people, when they look at a mandarin duck or a peacock or the absolutely baroque and beautiful structures of certain tropical birds, and they say that looks like a designer just kind of having fun, right? Something in their deep in their intuition tells them this is the product of a playful, whimsical, showing off intelligence. And is it really directly connected to reproductive success? And you get these incredibly complicated, implausible stories of sexual selection,
Yeah.
right? So not that sexual selection isn't real. I mean, I've seen it in action,
Yeah.
so to speak.
Yeah.
So I'm just appealing to the curiosity and desire for freedom of my audience, that, give yourself the greatest possible range of explanatory tools.
Yeah.
Let the evidence talk back to you,
Yeah.
right? Let nature talk back to you, and the
Yeah.
truth will emerge. I think John Maddox is going to be right. I hope he lives long enough to see the vindication of his perspective on the role of the genome. Dan Grauer, in a rare moment of absolute hostility, I think, I have to be blunt, called Matic a crypto creationist, which is really unfair because Matic, to my knowledge, I've read a lot of his work, I've listened to him give talks. He's never expressed any sympathy for intelligent design or creationism, but he is curious.
Yeah.
And he should not have the destructive label creationist hung around his neck like an albatross.
Absolutely not. And speaking about Dan Grauer, I just remembered something while you were speaking about I believe you covered the part of the presentation where he said if ENCODE is correct, then evolution is wrong. So the chief rabbi of the UK, Jonathan Sacks, he was a philosopher. He actually had a debate with Richard Dawkins, a very famous one. This was around the time of the ENCODE project. And I remember watching that. There's one part of the debate where Sacks, who's philosophically and scientifically quite literate, he says to Dawkins, well, we had this idea of junk DNA, but now ENCODE has shown that actually 80% or so is functional. And Richard Dawkins just moved around like this and he got really uncomfortable. And he said, well, I can see creationists are jumping on this, but I would answer back. I mean, I don't remember his words exactly, but he said, I would expect natural selection to not allow so much junk to just be retained in the system and sort of, just keep what's functional and flush out what's not functional. And he's trying to explain how natural selection would keep a clean and tidy apartment as opposed to all these artifacts of history. So I thought that was a very interesting answer because it's the very opposite of what Philip Kitcher famously said, and others, that God needs to go back to school if there's most of the most of the genome is junk, and all these other guys who were saying this stuff right decades prior. And I can actually, even though I can see, he hasn't really thought that deeply about it. I mean, it's just an answer in a debate. Well, I can actually see a Darwinist trying to explain that point. So I don't even agree with Grauer saying if evolution, if ENCODE's correct, then evolution's wrong. So, I mean, it seems like, yeah.
I didn't mean to interrupt you. I think the missing piece, which I did not have time to include because I wanted to try to stay within an hour, is a rather deep argument about so-called mutational load. That that it is not possible, given measured mutation rates and selective coefficients, to in each generation to purge deleterious mutations out of the genome. in other words, the selection can only monitor, if I can use that somewhat anthropomorphic verb, selection can only monitor a certain percentage of the genome. Everything else has to be let go.
Yeah.
And the mathematics here is somewhat complicated. I don't know if I'll have an opportunity to revisit this at some point in the future, but the missing piece of Grauer's argument is the concept of mutational load. And Grau and Moran and other sort of pro-junk theorists have as their targets not just intelligent design people, but also what they call pan-adaptationists, Darwinians or neo-Darwinians who see the hand of selection everywhere, that's finely tuning and finely crafting living things. So Michael Lynch is an example of this sort of critic of selection. So there is, in fact, an internal debate within evolutionary theory. And as I said, centering on, what can selection do? How many deleterious mutations can it purge in the time available? Anyway, I didn't mean to go off on a long digression about that.
No, I think these are very important points, because this embarrassing episode of ENCODE, which, even now they're trying to, deal with this scandal. It just goes to show how, when it comes to intelligent design, we can actually allow for a lot more things to fit within our paradigm. We even, to some extent, some junk could be there. We could we could have the Panglossian, whatever you call it, spandrels, right? We could have spandrels within a design structure. That's
right.
Perfectly fine. But what I find interesting is something which you said at the beginning. I've forgotten who said this, but I think it was Moran. Yeah, it's Larry Moran. He said, ID gives us a very different picture to what we actually see, or the words
right,
similar to this. What he's trying to say, and what I've heard others say, and I want you to really clarify this, because I remember you watching a talk of yours a few years ago, and you also mentioned a similar point, that when there are predictions being made on behalf of ID proponents from the Darwinists, they have certain conceptions, right? But they haven't justified those conceptions. So God would have done this. Intelligent design would entail this,
right?
And I've heard you deal with that in the past. And could you just deal with that again, because I think this is a point which is not addressed enough.
Yes, when you are explaining in a contrastive mode, where you've got a pair of competing hypotheses and you're asking which of them does a better job with the evidence, you need to be very careful not to make a straw man of your competitor, or to assume without justification that the competing theory is going to assert, A, B, or C about some state of affairs, when in fact the competing theory doesn't say that at all.
Yeah.
And the wellspring of this mode of reasoning was Darwin himself. So throughout the origin, he is comparing his theory, as he calls it, descent with modification via natural selection and other such processes, to really a not very well specified theory of creation. But it's clear that theory has some content, but it's content that Darwin has assigned to it. And I think if you read even the natural historians of the period, they were much more sophisticated in their understanding of what a theory of design would assert about the world than what Darwin did, which was to erect a designer sort of his own conception. And this comes right down to us in 2023. In fact, I have a book right over here by an Italian biologist called Imperfection. Right? A nice little slender book from, I think, MIT Press. I would never, as a design theorist, say that design predicted perfection. Never, right? So wherever he got that notion from, this Italian biologist, it wasn't from me. or frankly, any of the intelligent design theorists that I know. And I think, to be honest, we face the same problem. We should not erect straw man of evolutionary theory. I remember my advisor at Chicago in an early conversation. I was just getting to know him. He said, you know, Paul, it's no great feat to knock over a straw man. When you argue against a position, give it the best possible formulation that you can.
Yeah.
The principle of charity, right? Steel man it, don't straw man it. Give it the best possible formulation. And then if you're able to challenge it successfully, you will have really accomplished something.
That's right.
So for any evolutionary listeners to the stream today, I would encourage you, be very cautious about imputing things to intelligent design that it doesn't actually assert.
Yeah, definitely. And I would also just add to your point that conceptions of perfection or conceptions of fitness and optimization are hazy at best. I remember Rosenberg in one of his books a few years ago. I remember it's quite hilarious. He's giving an example of why a zebra doesn't have forearms that can turn into machine guns and take down, predators. So, I mean, anyone can say anything. Why don't we have bulletproof skin? So, I mean, even if we were to say, fine, things are not perfect, therefore intelligent design is wrong. What's your conception of perfect?
Right. Perfection is a very strange notion. If you just sit and reflect on it, it's open-ended at both ends.
Yeah.
There are infinities at both ends of that notion. And for that reason, I think a scientist or a philosopher ought to be very cautious in using it in an empirical context where you really want to be able to have operational notions that you can give to someone else and they can use them. You don't have to be there to help them along.
Absolutely.
Yeah.
Perfect. So those are some of the questions I had. I think this is a conversation which needs to continue. I know we only have a few more sessions left, but I'm really keen on getting all the juice out of your brain before you go on a little break.
I can tell you, I'm about to embark on a very aggressive book completion schedule. My book on common descent, with a goal of having a manuscript at a publisher by early summer next year. And one of the conditions of this project is that I not do things like this. Yeah. So I'm trying. It hasn't commenced yet. It will later in August. So I'm trying to get as many of these in.
Let's do it.
As I can. I'll send you all the references.
Brilliant.
And we'll schedule the next one. And my apologies for postponing this one.
No worries. No worries. Thank you so much, Paul. And for everybody watching, please make sure that you follow with all the previous series for this one to make sense, even though some of these are standalone. And I'm really, really looking forward to the future content. Thank you again, Paul, for having, giving us your time for this lovely session. Assalamu alaikum.